So there are 6 main inverse trig derivatives that you need to know to be able to solve longer chain rule problems. So the derivative of the inverse of sine is equal to 1 over the square root of 1 minus x squared when x is less than 1. The derivative of the inverse of cosine is equal to negative 1 over the square root of 1 minus x squared when x has to be greater or less than 1, sorry. And then the derivative of the inverse of tangent is equal to 1 over 1 plus x squared. And x has to be a real number. 3 more. And then the derivative of the inverse of cotangent is equal to negative 1 over 1 plus x squared. And x has to be a real number. 2 left. The derivative of secant, the inverse of secant, is equal to 1 over the square root of x squared minus 1 as x has to be greater than 1 this time. And then for the last one, the derivative of the inverse of cosecant is equal to negative 1 over the square root of x squared minus 1. And x, once again, has to be greater than 1. So let's try a few longer examples now. And we'll apply those formulas that we just learned, but with the chain rule examples. So let's say I were to tell you to find the derivative of, say I gave you 10 to the negative 1, 3x. Firstly, we need to identify the inside function here, which is 3x. So we can say u is equal to 3x. And then if we were to quickly differentiate that, u prime, using the power rule, would be equal to x. Or sorry, u prime here would be equal to 3, not x. Now we can apply the chain rule. So the chain rule in this example states that f prime of x is going to be equal to u prime of x, which we just solved for, over 1 plus u times x, or u to the x, squared. Now we can simply sub in, so that'll be u prime of x is equal to 3 all over 1 plus 3x squared. And then we can simplify that. F prime of x is going to be equal to 3 over 1 plus 9x squared. And that's our derivative. Let's try another example. Let's say I were to tell you to find the derivative of the inverse of, actually no, let's not do cosecant, let's just do secant. The inverse of secant to the 2x. Once again, we need to recognize that the inside function here is 2x. So we can say u is equal to 2x, and then u prime is going to be equal to 2. And then once again, we can apply the formula. So f prime of x is going to be equal to u prime of x all over u to the x times the square root of u to the x squared minus 1. And then when we sub the values in, we're going to get 2 for u prime of x all over 2x times the square root of 2x squared minus 1. And then when we simplify this, f prime of x, or the derivative, is going to be equal to 2 all over 2 times x times the square root of 4x squared minus 1, which can be simplified further to 1 over x times the square root of 4x squared minus 1. Let's try one last example. Let's say I were to tell you to find the derivative of the inverse of sine to the x squared. Once again, here we need to find the inside function, and that's going to be x squared. So u is going to be equal to x squared. And then using the power rule, we can differentiate this to 2x. And then from here, we can apply the chain rule. So f prime of x is going to be equal to u prime of x all over the square root of 1 minus u to the x squared. When we substitute the values in, this is going to be equal to 2x over the square root of 1 minus x squared squared. And then we can simplify this to give us 2x over the square root of 1 minus x to the power of 4. I hope this video helped. Thank you.